This is the third in a series of videos preparing you for pre-AP chemistry, and it's called What is Density? As we look at the physical properties of elements and compounds. Density. The word density has many connotations, but in science it has only one, denotation. For instance, one dictionary says something is dense when its parts are crowded together. It says a person is dense when that person is ignorant, even stupid. Now, we have to understand, such words are judgmental and they are very inappropriate. But in science, density is defined as the quantity of anything per unit of area or volume. And it can be applied to matter or other things, even the populations of plants or animals in a given area. However, our scientific physical science definition of density is only one meaning. It's the mass of a substance divided by the volume of that substance. The unit of density is kg divided by m cubed. In chemistry, we usually use g, grams, divided by cm cubed, or grams divided by ml. We say in English kilograms per cubic meter, or on the right, grams per cubic centimeter, or for liquids, grams per milliliter. So let's calculate a density. Shania measures out a volume of distilled water and finds that her beaker contains 32.65 milliliters of water. Now, she wouldn't measure in a beaker. You'd measure with a graduated cylinder or a syringe or volumetric glassware, not a beaker. But that's her number. When she massed the dry beaker, that container, it had a mass of 54.26 grams. The mass of the beaker and water together was 86.91 grams. Calculate the density of distilled water under these conditions. Let's see how to do that. Shania needs to find the mass and the volume of the water alone. She has the mass and the volume. She has the volume of the water, but she has the mass of the beaker and the water together. So she subtracts the mass of the beaker from the mass of the beaker with the water in it. So turn this video off and do that calculation. Then turn the video back on when you're through and check your work. The water is 86.91 minus 54.26 grams, or 32.65 grams. Now she has the mass of the water and the volume. To find the density, she must divide the mass in grams by the volume in milliliters. 32.65 grams divided by 32.65 milliliters. Hopefully you can do that one in your head. Your answer is 1.00 grams per milliliter. There might be another zero at the end of that for significant digit purposes, but you'll learn that this next class. So, the density of water at lab temperatures is always very close to 1.00 grams per milliliter. We suggest that you remember the density of water for use this year and in future years. Let's calculate another density that maybe has a little bit more math to it. Mehdi needs to find the mass and volume of a copper slug so he can calculate the density. He measures the volume of the slug by water displacement and finds it's 26.2 cubic centimeters. The mass numbers you see here are on the table on the right. So calculate the mass of the slug and then calculate the density of this copper slug. Turn the video off, and then when you're through with your calculations, you can turn it back on and check your work. The slug alone is 234.8 grams by the subtraction process. We then divide the mass in grams by the volume in cubic centimeters to find the density. That's 234.8 grams divided by 26.2 cubic centimeters, or 8.96 grams per cubic centimeter. That's confirmed by an internet search for the density of copper. Are density calculations useful? Well, yes, they are. If you have two objects and want to see if they're really made of the same substance, finding the density of each will help you. If the density of object 1 is very close to that of object 2, and they look alike, chances are that they're made of the same material. There is a story that's come down to us from Greek history that you might want to watch, the story of Archimedes and the gold crown. You can stop this video and click on the link and watch it to see a very interesting, less than 10-minute explanation of this historical oddity. And let's give you a teaser to show you how density calculations might be useful. You probably know that the organizing template behind all of chemistry today is the periodic table. And this is a picture of the original periodic table. You know that the elements in each column of the periodic table have similar properties, similar chemistry. When you study chemistry this next year, you'll see how Dmitri Mendeleev, 150 years ago this year, used density calculations to construct his table, and he even magically predicted the density of elements that had not yet been discovered. That's a wonderful story that you will read about this coming year.